Hey everyone, in this video we'll learn how to solve radical equations. And radical equations are simply just equations where the variable, in our case x, is under a radical. It's the radicand of a radical. And let's go through an example together. Let's say we have radical x plus 5 equals x minus 1. And our goal, as always, is to solve for x. We have x on both sides of the equation. On the left side, it's underneath a radical, and on the right side, it's not. So our goal is to isolate x, just like in any equation. So how do we do it in this situation? Well, as you could see right here on the left side, our x is trapped underneath the radical. So what we can do to cancel this radical, we can take the square root of both, we can take the square of both sides. So we can raise both sides to the power of 2. So what that does to this radical will cancel out with the squared, and we have freed the x plus 5 that was trapped within it, so x plus 5 is now free, equals, and on the other side, we have x minus 1 squared. Perfect, so let's actually focus our attention to this side now. Now we have x minus 1, all of it squared inside a set of parentheses. So let's go ahead and evaluate this. So let's just rewrite this, x plus 5 equals, and what is x minus 1 squared? That is just x minus 1 times x minus 1, which we can solve with FOIL. So let's go ahead and use FOIL on this thing. So again, let's rewrite this, x plus 5 equals, and we will do FOIL. So the first, the outer, the inners, and the last. So what is x times x? That is x squared. X times negative 1 is negative x. And negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. And these two like terms, negative x and negative x, are both like terms. So negative x and negative x, they can both be combined to negative 2x, negative 2x. And let's just write everything else down. So x squared and then plus 1 equals x plus 5. Okay, we're getting very close. So this is starting to look a lot like a quadratic. And we know how to solve those, but before we try to solve it, let's get it in our ax squared plus bx plus c form equals 0. And how we're going to do that, we are going to move the x and the plus 5 over to this side. And let's just do that one by one. So let's subtract both sides by x. So we'll subtract both sides by x. That will cancel that out. So on the left side, we're left with a positive 5. So 5 equals, and then we have to see what we can subtract this x with. We have two like terms here, negative 2x and negative x. So negative 2x minus x is negative 3x. So let's write that, negative 3x. And then we'll write everything else down, x squared, and then plus 1. And again, these are like terms because they have the same variable x to the same power, to the power of 1. So now that we have that, 5 equals x squared minus 3x plus 1, let's go ahead and move the 5 to the other side. So subtract 5 from both sides. And on the left side, we have 0 equals. And on the right side, we can subtract 5 from the positive 1, since now these are both like terms, positive 1 and negative 5, because they are both just numbers with no variables. They're just constants. So what's 1 minus 5? That's negative 4. So negative 4. And we'll write everything else down. So x squared minus 3x. So x squared minus 3x minus 4 equals 0. And I actually want to just reverse this. X squared minus 3x minus 4 equals 0. Just so when we solve this, then we can have x on the left side, x equaling something. Excellent. So Now we just have a quadratic equation, and it's up to us how we want to solve this. We can complete the square, we can try to factor it. It is totally up to us. So I will go with factoring it. So let's set up our factors, x plus, x plus. We have our a, b, and c. So our a is 1, our b is -3, and our c is -4. Okay, so -4. What two numbers multiply to -4? There's -2 times +1. And there's also, or apologies, there's -2 times +2. And there's also -4 times +1. And there's also -1 times +4. So which of these can add up to -3? So right here, as we could see, -4 and +1, because -4 plus 1 equals -3, which is our b term. Our b term is -3. So we can use -4. So we can go ahead and use -4 and +1. So we'll put a -4 here and a +1 here. And then x plus -4, that's just the same thing as x minus 4. And that all equals 0. Perfect. So we factored it. It equals 0. We can go ahead and split this up to x minus 4 equals 0 and x plus 1 equals 0. And we can just go ahead and solve for x on both of these equations. So plus 4, and we have x equals 4. And then on this side we have, so we'll subtract 1 from both sides, -1, -1, x equals -1. Okay, so we have x equals 4 and x equals -1. Now we have to be very, very careful. We are actually not done. Even though it looks like we've solved for x, we have x equals 4 and x equals -1. The thing is, with radical equations, with our radical equation, so let's actually rewrite this. So square root of x plus 5 equals x minus 1. So let's rewrite the original problem down here. Square root of x plus 5 equals x minus 1. So for radical equations, it's very, very important to check for extraneous solutions. Check for extraneous solutions. Extraneous solutions pop up in radical equations. And what an extraneous solution is, this is very important. It's a solution that doesn't actually work when we plug it back into the original equation. And there's a reason why, but first, let's go ahead and test both of these solutions. We have x equals 4 and x equals -1. They both could be solutions, or maybe they're not solutions, but we have to test them. So let's test the x equals 4. So right here, we are going to substitute x for 4. So radical 4 plus 5 equals 4 minus 1. So 4 minus 1. And let's go ahead and evaluate this. What's 4 plus 5? That's 9. So radical 9 equals 4 minus 1. So 4 minus 1. And 4 minus 1 we can evaluate to 3. And then evaluate the left side. So what's radical 9? That is 3. So 3 equals 3. So that actually works. So 3 does equal 3. That's correct. Therefore, x equals 4 is a solution. X equals 4 has passed the test. It's not an extraneous solution. But now let's check x equals -1. Let's go ahead, go back to our original problem. So let's get rid of this. We've proved that 4 works. And now let's substitute x for -1. So let's rewrite this as the square root of -1 plus 5 equals -1 minus 1 minus 1. And let's go ahead and evaluate this. So let's evaluate what's in the radicand. -1 plus 5 is 4. So we have radical 4 over here equals, and right here, -1 minus 1 is -2. Okay, so what's radical 4 to evaluate to? That is, radical 4 is +2 equals -2. And check this out. We have 2 equals -2, which is not correct. 2 does not equal -2. In fact, quite the opposite. Therefore, what we plugged in for x, this -1 right here, this is an extraneous solution. X equals -1 is extraneous. Even though we've gotten x equals -1 by solving the polynomial, by solving the quadratic, by algebraically solving for x, when we plug it back into the equation, x cannot equal -1. And that is because if we go back to when we plugged in -1 right here, our -1, -1, whatever's underneath the radical, at the end of the day, this is a positive radical. So the square root of anything will always be a positive number. The square root of something cannot, this is a positive radical right here. So whatever this radical comes out to, it will come out to a positive number. This came out to a +2. And on the other side of the equal sign, we have a -2. Because when we substituted x for -1 over here, we came out with a negative number equaling this radical. But this is a positive radical. So that's what makes the solution extraneous. And that's why x equals -1 cannot be an answer, and x equals 4 is the only real answer. So you have to check your answers, you have to test your answers before you can say that you've solved for x. And that's really important. So let's go through a slightly more complicated example together of a radical equation. Let's say we had the square root of x minus 5 plus the square root of x equals 5. Okay, so this one's a little more complicated to solve. We could try to raise both sides to the power of 2, and in fact, let's go ahead and do that. So let's raise both sides to the power of 2. So we already know what the right side is. 5 squared equals 25. So let me write that here. We'll need a lot of space because we are raising to the power of 2 this binomial over here. Radical x minus 5 plus radical x. We have two terms, 1 and 2. So whenever we square a binomial, we can go ahead and expand it out and use FOIL, similar to what we did in one of the steps to this problem up here, where I believe we had x minus 1 squared right here, and we went ahead and expanded it and used FOIL. We can go ahead and take a shortcut. And the shortcut I mean is whenever we have any binomial a plus b squared, that always equals a squared plus 2ab plus b squared. So I'm going to use this rule to expand this binomial right here. So a squared plus 2ab plus b squared. So let me go ahead and just move this. And let me just go ahead and move this. I'll move it up here so I remember. Let's just put it up here. Okay, so in order to expand this binomial over here, what's a squared? So this is our a in this case. I'll put it in green. And the b I'll put in orange. Right here, the radical x is the b, and the radical x minus 5 is the a. So what's the a squared? Well, what is radical x minus 5 squared? Well, as it turns out, the square root and the square cancel out, so this is actually just x minus 5. So I'll just write x minus 5 plus 2ab, so 2 times a and b, so a is radical x minus 5 times, and then b is the orange radical x. Perfect. And then plus b squared. So what is our b squared? So our b is radical x, so radical x squared. And again, as it turns out, the square and the square root cancel each other out. So, or apologies, the square and the square root. So the square and the square root right here cancel each other out. So we're actually just left with x. So right here, let me just rewrite it, x. And again, this all equals the 25 that we evaluated on the right side of the equal sign. 5 squared is 25. Excellent. So let's go ahead and keep evaluating this. Do we see any like terms? Well, as a matter of fact, we do. We see right here x plus x. So we can just combine those to be 2x. X plus x is 2x. And let's write the rest of this down. Minus 5 plus 2 times x minus 5 under a radical times radical x equals 25. We can do a couple more things. We can go ahead and, let me just put that back. We can do a few more things. We can go ahead and move this negative 5 over here, this minus 5, to the other side by adding 5 to both sides. If we scroll down, we have 2x plus 2 radical x minus 5 radical x equals 25 plus 5 is 30. Okay. And let's continue solving this. We have these two radicals being multiplied right here, radical x minus 5 times radical x. So one of the laws of radicals that we've learned in a previous video is that in this situation, we can multiply both radicands. So let's rewrite this as radical x times x minus 5. And let's just write everything else down. Let's put a 2 there, and we'll bring that 2x over there, and that all equals 30. So let's go ahead and distribute this x times x minus 5. Let's distribute the x. So what's x times x? That's x squared. And then x times negative 5 is negative 5x. So that's all underneath a radical. Let's write everything else down to x equals 30. Okay. And we're getting close. So ultimately what we'd want to do is we actually want to isolate this radical so that we can square both sides. So let's actually move this 2x to the other side of the equal sign. And we have 2 radical x squared minus 5x. So minus 5x equals, so we could write 30 minus 2x like this. But I actually want to keep it in this form with the variable first, so negative 2x plus 30. So let's keep it like that. And then let's get rid of this 2 by dividing both sides by 2. So that cancels that 2 out. And we are left with radical x squared minus 5x equals, and what is this binomial right here, these two terms divided by 2? Well, let's divide each term by 2 first. So what's negative 2x over 2? That is just negative x. So negative x. And what's 30 over 2? That is positive 15. Great. So now to get rid of this radical right here, we are going to raise both sides to the power of 2. And that square will cancel the square root, the radical. And right here, we have freed this radicand. X squared minus 5x, so that is now free, equals, and now we have another binomial here that we're going to expand. So we can actually just copy that same rule that we've written down, a squared plus 2ab plus b squared. instead of having to use FOIL and expand it ourselves, we can go ahead and just use this rule. Super helpful. So the A I'll underline in green, so that's the A. And the B I will underline in orange, so that's positive 15 is the B. So what's A squared? What is negative x squared? That is just x squared plus 2 times A times B. So 2 times negative x times positive 15 plus B squared. So B is 15, so I'll just leave that as 15 squared. Let me just make that orange, so 15 squared. Great. So we're getting close. Now let's just go ahead and keep evaluating this. What is 2 times negative x times 15? Well, what's 2 times negative 1? Remember, this negative x, there's a negative 1 coefficient in front of it. 2 times negative 1 is negative 2. And negative 2 times 15 is negative 30. So this is negative 30x. Let's write everything else down. Plus 15 squared, x squared equals x squared minus 5x. And let's now try to isolate x. So we can actually subtract both sides by x squared. And what that will do, that will cancel x squared on both sides. And we are left with, let's just write it here, negative 5x equals negative 30x plus 15 squared. We're getting very close, so now let's go ahead and add both sides by 5x. So plus 5x plus 5x. These are like terms, negative 30x and positive 5x. So those will cancel. And on the left, we have 0 equals, and what's negative 30x plus 5x? Well, what's negative 30 plus 5? That's negative 25. So negative 25x plus 15 squared. And let's actually, in order to continue to isolate this x, let's go ahead and subtract both sides by 15 squared. And we have negative 15 squared. So let's actually just write, let's switch the order of these. So negative 25x equals negative 15 squared. And now let's go ahead and, in order to isolate x, we're going to divide both sides by negative 25. So negative 25 there, and negative 25 there as well. So x equals negative 15 squared over negative 25. Negative 15 squared over negative 25. So let's keep evaluating this. So what is 15 squared by itself? 15 squared is 225. So this is really negative 225 in the denominator over negative 25 in the negative 225 in the numerator and negative 25 in the denominator. And this actually comes out to positive 9. Therefore, x equals 9. That is the solution. Now, again, with any with any radical equation, this isn't the solution yet. We have to now check it. So let's go back to our original problem. All the way up here, radical x minus 5 plus radical x equals 5. So let me rewrite that down here, our original problem. So radical x minus 5 plus radical x equals 5. And we are going to test this 9 right here. So let's substitute x for 9. So right here we have radical 9 minus 5 plus radical 9, instead of radical x, radical 9 equals 5. Okay, and then What's 9 minus 5? That's 4. So radical 4 plus, what's radical 9? That's 3. And then radical 4 we can also evaluate. Radical 4 is 2. So 2 plus 3 equals 5. And what's 2 plus 3? 2 plus 3 is 5. So 5 equals 5. And that is true. 5 does equal 5. So that receives a check mark. Therefore, our x equals 9 solution is correct. It's not extraneous. And that's how we find our solution. X, in fact, does equal 9. And that's how we solve radical equations. So the trick is to really just get the radical by itself on one side of the equal sign, and then square both sides to get rid of the radical. And sometimes it turns into a higher order polynomial, something that you have to factor, that you have to use other methods to solve, one of the types of equations that we've learned in previous videos. But after doing all that, then you will eventually be able to solve for x. And the important thing to remember is that sometimes you can have extraneous solutions. So you have to be very careful. Once you have x equals something, you have to check that number. You have to test it, and if it passes the test, then that is the solution to x. So I hope this video helps, and if you have any questions at all, please leave them down in the comments below, and thank you for watching.